So the goal for today's video will be to fabricate the mold. We'll be making the upper part, the lower part, and attaching them to the lathe and finding whether they can get synchronized and precisely aligned together. We will skip the inserts, the mold inserts. We'll leave them for the next video. So these brass parts will not be made today. First we have this flange that will be mounted to the faceplate of the lathe. This is the registering edge that will precisely position it. Then we have this part that will hold the brass part with all the holes for the pins. And finally, flange here that will hold locating pins. I made some change here from the last video. There were a couple of comments from you. Thank you again for them, suggesting to change the way how the two flanges were mating together and use locating pins instead of the weird things that I designed in the previous video. This is a standard solution for injection molded dies, and we can use it here in our mold as well. Now the bottom section, it's the same flange here, flange with holes for the locating pins here, and here we have a hole for second part of the brass die, which is here, and finally movable part that will help us to eject the finished stem after the forming. And the interesting part here is how to connect the parts between themselves. We have different joints here. So for instance, this one between the flange and the shaft here, this is a permanent connection, while here the pins needs to be sliding in the holes. They needs to be sliding here because we will be inserting them by hand into the holes, and so on. So let's start with this connection here. We want to press it on a press so that it stays together permanently, which means that the internal parts needs to be slightly bigger than the hole, and the slightly is actually standardized. The way how the parts comes together is called engineering fit, and I will not go into details on this one. There is a great video on YouTube by Quinn from Blondie Hacks explaining everything about the fits and tolerances. It's absolutely perfect video, and I recommend to check it out if you don't know what I'm talking about here. So for this connection I chose fit that it's called press fit. It's a light interference which can be assembled or disassembled with cold pressing, hubs, bearings, bushings, retainers. And the tolerance zones are here H7, P6. So H7 is for the hole and P6 is for the shaft. So now we need to calculate these zones into numbers. There is a website called Theoretical Machinist which will help us with this task. So we enter 42 as our nominal diameter, and we'll be using H7 for the hole and P6 tolerance for the shaft. And when we hit the calculate button, we see our dimension ranges. So for the hole it will be within this range, and for the shaft we need to stay within this range. And now practically translated to the drawing. Here we are for the shaft, and here we have dimension for the hole. And we have a new baby that will help us with this task. I still haven't told you that we got a new big lathe, and because it was really big we didn't have space for it at the castle, so we had to rent a little factory building for it. So the flanges and the shaft of the lower holder were finished, and before pressing them together we had to cut these slots. The purpose of the slots is to fine position them on the faceplates of the chucks. I never thought of using our CNC router for cutting the steel until I saw this video by breaking tabs. We have a different machine, but it was worth trying the parameters displayed in the video by breaking tabs, and I found that it actually can cut the steel. We just need to run the machine a lot slower, and also we need to use lower depth of cut, and probably also the machine doesn't like this, especially the bearings in the spindle, but it does the job, and from time to time I think we can simplify our life by abusing it a little bit. Machining of the steel and pressing the components together turned out beautifully, so we could continue with our CNC router, and I programmed it to cut the slots for the ejector pins. For this operation we used a 4th axis and the same cutting speeds and feeds, and also this time there were no complications. Now it was the right time to machine this edge, which will accurately position the mold holder in the chuck of the lathe. To make sure that this part is as much perpendicular to the faceplate of the glass lathe, it was necessary to wait until we have these two parts connected together, and then the plan was to machine this edge when holding this part between the centers in the lathe. The next task was to machine these two flanges. Their purpose is to hold these locating pins that align the molds together. They take care to have the molds, the upper and lower section aligned. And also here we need to decide for the fits. So here we have, so the connection of the flange to the body of the holder will be done here with press fit, like in the first case. And here we will use a sliding fit. The definition of the sliding fit: minimal clearance is for high accuracy requirements, which can be easily assembled and will turn and slide freely, e.g. for guiding of shafts, sliding gears, crankshaft journals. Anything more accurate would be how to machine, and also because we will have temperature changes here, it could get completely stuck during the work, so we will stay with sliding fit. So the tolerance zones here are H7, G6. The H7 will be for the hole, and we will make it with the reamer, and the pin will be turned to G6. And practically for the hole we will be within this range, and for the shaft, for the pin, we will need to turn it into this diameter. Co? Ideálně. No, klidně ještě půl minuty. So the holders are finished, mounted, and I can see some movement here, which is not good, but maybe it will be acceptable. So the runout on the face is some 400s. Some 0.2 of millimeter runout is in the seat inside, so that's quite a lot. Around 700s on the face of the other side of the mold holder. And inside of this seat we have over 0.2 of a millimeter runout. So I mounted here the locating pin. The purpose of the pin is to precisely locate the two halves of the mold together. The pin itself and the hole are machined precisely with very little clearance between them. But because the two halves are not very precisely located, we will see if the pin can get into the hole and synchronize the two molds together. Like, there is some play in the heads, in the chucks, but we will see if this is enough. And I also have to adjust this. Now we have both sides synchronized with these slots. I move it a little bit and now I can turn on the machine and see how smooth it runs and how smooth it goes together. I don't know if you see it, but when I put it together, the whole right side starts moving. So probably not the best for the machine, but for us, for a couple of prototypes, it could work.